I lead the Intelligent Interactive Systems group at Harvard. I guess if I was starting today, I might call it Human-AI Interaction Group, but this was 2009. I was very interested in what happens when people, human intelligence and machine intelligence meet, and that was the best phrase that came to my mind at the time. Before I dive into the content, I really want to acknowledge that I do this work with a number of very fantastic collaborators. The newest one, Gianna, is actually a graduate of Stanford, so you guys are influencing me. To set the stage, I think human-AI interaction as a field, and I will use intelligent interactive systems and human-AI interaction interchangeably, is a very interesting extension of the classical human-computer interaction. Like, we strive to create systems that are useful, predictable, and give people a meaningful sense of control, just like classical HCI folks. But we face very interesting challenges because the material that we work with, the machine intelligence, is occasionally wrong. So how do you build systems from which people derive real value? They are complex. So how do you give people a sense of predictability and knowing what the machine is going to do? And often we really want the intelligent systems to act proactively, and yet, we want to give people meaningful sense of control. So these are fun challenges that go beyond prior knowledge in human-computer interaction. What's important is a bit of history. This is taken from the Interactions magazine from 1998 or 1997. This is debates that occurred in 1997 between Ben Schneiderman, whom I hope you guys know about, and Patty Maas, who was one of the leading researchers on intelligent agents, so proactive machine learning systems that do things on behalf of the users. And they battled. Notice that the title of the conversation is Machine Direct Manipulation versus Interface Agents. It was, the presumption was that the two could not coexist. Ben argued that people need a strong sense of control and that intelligence inherently and inevitably will confuse people. Patty was arguing, but look at the benefits that we can deliver. And because the two communities spoke in somewhat different language and had different objectives, if you went to conferences at the IUI conference, the Intelligent User Interfaces conference, you would have a lot of people with AI backgrounds building interactive systems and showing off the capabilities of those systems, but not necessarily worrying about usability and measuring whether people's satisfaction or performance. And then you had conversations happening at the HCI conferences where people presumed, without again empirically testing it, that machine intelligence was inevitably too complex and unpredictable to result in useful systems. So for a very long time there was too little productive conversation. The conversation really started around 2000. So the first point that I want to make is that we're facing novel and very interesting and difficult challenges. And second is that the field is relatively young. And despite our youth and the challenges that we faced, as a community, we have produced a bunch of useful knowledge, and I'll give you one example of it. But also, something very interesting has happened several years ago, the newest resurgence of AI. And suddenly, AI is being sprinkled everywhere in lots and lots of interactive systems. We are moving incredibly fast, putting AI in places where it never belonged and using it in ways that we've never used it before. So we have to build stuff, and along the way, because our knowledge that exists in the field is fragmentary and incomplete, we are often turning assumptions, very reasonable sounding assumptions into the fundamental tenets of our field, and we build on them, and we never have time to pause and verify, are these assumptions actually sound? Initially I was going to say we need to slow down, but I realized that one never says that in the heart of Silicon Valley. So instead, I'm saying we need to accelerate the production of design knowledge to catch up with reality. So this is kind of the high-level vision for my talk. Let me start with one kind of one area of human-AI interaction where we did produce some useful knowledge that actually got incorporated into real systems, and that's the area of adaptive user interfaces. So back when HCI was young and computing was young, the systems that we produced were simple. And we figured out how to build direct manipulation systems that people could really comprehend, very quickly explore, and know what to do with them. And then those systems started getting more and more and more and more complex, and suddenly things started breaking. It was becoming a little bit harder to use them well. Professor Joanna McGrenery characterized it pretty well and demonstrated that most people used only a tiny fraction, maybe up to 20% of the features available in any piece of software. The challenge was that different people used different small fractions of the available features. So we couldn't just simplify the software because all of the features got used by someone, but any one person would have benefited from a simpler design than whatever was shipped. An interesting design got tried commercially by Microsoft. This is the smart menus, and notice what happens. The smart menus can expand. So the default version of the smart menus shows you only a fraction of the features available in the system, and the fraction that is showed to you includes things that everybody needs, like copy, paste, edit, and also things that you've recently used. So if you've used some features, they become immediately visible, but some things that are deemed as rarely used and things that you've never touched get hidden, and you don't get to see them until you ask the menu to expand. So the menu expands if you press on this button at the bottom, or if you do a lot of fanning across the menus, then it expands. This feature was accepted by roughly half of the users, and I think John may have like really good information, possibly. But roughly half of the users found it challenging in various ways, and eventually this design got abandoned. Even though the field was fairly young, a number of people, including myself, attempted to systematically explore the design space of adaptive user interfaces, trying to understand what might be the strategies through which we can build adaptive user interfaces that make people productive, that make people happy, that give people a meaningful sense of control. And there are a number of things that as a community we have learned. So one was that unlike in traditional HCI, when you create simplifications, you really reduce the work and load on people. When you use machine intelligence to make some aspects of interaction simpler, you often add some new cost. You often require people to pay just a little bit more attention than they did before. You require people to think just a little bit more. So we've learned that what we are doing is not just pure savings, but a bit of a trade-off. And we really need to pay attention to the main work, like amount of clicking, but also how much attention, cognition, and visual search people need to perform to take advantage of it. We also learned another thing, and that took us a while. We discovered the loss aversion cognitive bias. So we've realized that when we built interactive intelligent systems, people's perceived cost of AI's mistakes is huge, but they give AI relatively little credit for the things that the AI does well. So this means that we really have to design these systems not such that there is a net benefit, but that there is a huge benefit of the AI with respect to, compared to the possible costs that people are going to incur. And we have to assume that there are going to be costs because still AIs are less than 100% correct. And very nicely, what came out from all of this activity, both commercial and research, is a design pattern of split user interfaces. So the idea is that if AI is being used to make some existing interaction more efficient, a robust design is not to replace the existing way of doing things, but provide an alternative. So that people who want to turn off their brains and just go on autopilot can do things the way they always did, or they can use the alternative design. So here are some designs in commercial software. So frequently or recently used fonts get copied to the top of the font menu so that you can access them if you are paying attention, or you can scroll all the way down to Times New Roman. Predictive text gives you an option to select a word completion or a word prediction, but you can just keep typing without paying attention to it. On your iPad, the operating system is suggesting a software that you are likely to use that is not part of your taskbar based on context and your prior usage. But you can still access it via regular channels. So this is an example of an area in human-AI interaction where we have produced useful knowledge. That knowledge has survived the test of time. It is being used commercially and in research. It's great. The rest of the talk will be about places where we thought we knew, but it turned out that we didn't. And the first example is predictive text. So when predictive text got developed, we assumed that we're building a smart system that will make people more efficient at inputting text without having any impact on what people write. After all, people are in control. It turns out that this assumption was not quite correct. Here is one experiment that we conducted. We asked people to write captions for images, and we created our own predictive text systems that we controlled completely. And before I show you the results, let me define the word predictable. We define the word to be predictable if the language model that we used in the study predicted this word to be the next word the person will input. And in this system, we did not predict word completions. We predicted the next word to enter, so just entire word predictions. What we found, unsurprisingly, is that when people used the predictive keyboard, the text that they produced, the word choices were more predictable. So they were more likely to use words aligned with the predictions of the underlying language model than if they did not see the predictions. And the mechanism that we saw frequently was that people would substitute the word that they meant to write with one that was easily available. So for example, a person might be thinking, a train is approaching the station, but because the system proposes the word on, they choose the word on instead. More surprisingly, it turns out that people who were given predictive text keyboard wrote shorter captions than people who did not. And this was unexpected because predictive text is supposed to make it easier and faster to enter text, so we thought people would write more. Instead, what happened was that we realized that the predictive text very rarely suggested adjectives, adverbs, or other embellishments. So for example, if a person wanted to write an old train is approaching a quiet outdoor station, the outdoor word would not be predicted, but the subsequent word station would be. So people often skipped adjectives, adverbs, and other embellishments, resulting in simpler and shorter captions. So this study demonstrated that there is an impact on content of what people write from this design. This is already, possibly concerning because, it makes all text written with this technology more alike. But we also wondered what would happen if the underlying model had a substantial bias. So, we both looked at how a biased corpus impacts the algorithm, and then also we looked at what is the impact on what people produce with this. The study that we designed was one in which we asked people to come in and list 4 recent restaurant experiences. This was before COVID, people were still going to restaurants. And we asked them specifically to try to think of 2 positive experiences and 2 negative experiences. And we asked them to write down those restaurants, and we asked them to assign star ratings to each of these experiences. Only after they've done that, we randomized these experiences to 2 conditions. So we trained 2 language models, both on Yelp data set. One of the models we trained predominantly on positive reviews, and one we trained predominantly on negative reviews. And then we randomized people's restaurant experiences such that 2 of them, one positive and one negative, would be written with the assistance of a predictive text trained on positive reviews, and the other one based on negative reviews. So people then wrote those reviews, but remember that they were already committed to the star rating. And then we asked external raters to read all of these reviews and say, just without seeing the star ratings, say, just given the words, how positive or how negative were these reviews? And we found a substantial effect of of the language model on the content of the reviews that people wrote. So people were already committed to what they were going to write, they wrote it, and the suggestions given by the language model substantially affected how the text that they wrote was perceived.
So just a quick question, what's the y-axis measuring? Number of positive words?
It was I can't exactly remember what measure we used, but we asked raters to just rate the, so this is subjective human ratings of the reviews.
Okay.
So we as a community, we built predictive text systems to make people faster without affecting what they write. It turns out that we're incorrect. The predictive systems do change what people write. If the system is biased, that bias gets reflected in what people do. And we had another paper, which I didn't mention, that shows that the effects of the impact of the suggestions is greater if we suggest phrases rather than words. And at that time, 8 years ago, this was still science fiction, but now it's actually reality, right? We suggest very, very large chunks of text to people. Okay, next area, more contemporary, AI-assisted decision-making. So here, roughly in 2019, we started really talking about explainable AI, and we thought, all right, we're going to assist people in the decisions that they make by giving them decision recommendations and explain why these decisions were recommended to them. And we assumed that this is going to lead to good decisions. Just to have some concrete example in mind, I'm specifically thinking about what might happen in a clinician's office when a clinician has to come up with a treatment for a patient. So a clinician enters the decision situation, the system predicts these are the best treatments for this particular patient and for this particular reason. So when the work on AI-assisted decision-making started, we all believed that what is going to happen is that people and AI will have different accuracies, and when you combine the two, you will inevitably get better outcome than from either of the components alone. And anyone who has learned about ensemble classifiers or ensemble techniques in machine learning knows that if you combine two systems that make independent errors and and do something sensible with those outputs, you get an ensemble that performs better than any of the components. Like, it was inevitable. It had to happen, except that it didn't. People assisted by AIs actually did poorer than the AIs, often better than they would have done on their own, but poorer than the machine learning systems on their own. It took us a while to figure out that this was actually happening, because for a long time we weren't testing people's decision-making with the AI assistants. Instead, we were testing people's predictions of how the models would behave. And it turns out that this wasn't a particularly good measure of progress. But once we started measuring how people actually make decisions with these systems, we noticed this. And we realized that what's happening is that people appear to over-rely on the AI. So notice that when AI is incorrect, people often make poorer decisions than they would have on their own, because they were swayed by the AI in the wrong correction. So the issue was not to increase trust in AI, as we believed for a while, but to calibrate the trust potential. And in one of our own studies, we looked at how clinicians make treatment decisions, and we indeed found an evidence of over-reliance, and we found that explanations did not improve the situation. And this idea that explanations were actually not improving the situation was spotted by a number of people. One of the first explorations of this idea came from Gagan Bansal. And in his paper, he noticed that when explanations were added, people often did not engage with the content of the explanations, but instead took the mere presence of the explanations as an indication that the system was competent. So they would over-rely on the system without engaging with what the system is actually saying. There is another very recent paper that also suggests that when people try to decide whether information that they are receiving from someone is credible, and they do not know the field particularly well, what they pay attention to is the number of concrete facts or things that sound like concrete facts that is being communicated. And if you see a lot of concrete facts, you believe that the person is competent. And notice that the way we design AI explanations is often by producing a very large number of concrete facts. So the way we are designing the explanations really encouraged people to perceive AIs as competent, even without people having to engage with what the system is saying. Just the superficial features led to that impression. So at that point, our mental model was that, indeed, the explanations may have some impact on how people make their decisions, but there is this element of human cognitive engagement that moderates this effect, and that in the current design, people actually are not engaging with the content of what the AI is saying. So we dug into the literature from medical decision making, and one of the ideas that we found there is the idea of cognitive forcing, intervening at the moment of decision making to interrupt heuristic and superficial decision making and encourage people to engage more deeply with what's going on. So we already believed that people engage superficially with the AI-generated content, so we thought, all right, if we interrupted this superficial engagement and got people to engage more deeply, would we see a decrease in human over-reliance on the AI? So the way we implemented cognitive forcing, we actually tried several different techniques, but one that is particularly effective and that many other people have used is one where people are asked to make their decision on their own first, and they record that decision, and only then they are shown the prediction and explanation from the system, and then they are asked whether they want to revise their decision. So they've already thought about it, made the decision, they're confronted with potentially different recommendation from the system, and then they have a chance to combine the two pieces of knowledge. What we found was that indeed, and notice that the results that I'll show here are only for situations when AI suggestions are incorrect. So we found that people who are given the traditional recommendations and explanations over-relied on the AI a lot. They rarely made correct decisions if AI suggested an incorrect option. But if we use this cognitive forcing strategy, people over-relied on the AI less. Still over-relied on it, but over-relied less. So we felt pretty positive about this result, and our updated mental model at that point was that cognitive forcing was indeed leading to greater human cognitive engagement with the content, and that we're heading in the right direction. Then we decided to probe human cognitive engagement in a different way, and specifically we used the concept of incidental learning. So the idea is that if I need advice on a decision-making task and I ask somebody for help, for example, Dan, I ask him, how should I search for something super complicated? He will tell me, and I will do a better job on the task in the moment, but presumably I will learn from this interaction in such a way that the next time I am performing complicated search, I'll do a better job on that as well. I will retain something from this interaction. This is called incidental learning, and this is, by some accounts, roughly half of the learning that occurs in modern organization happens through some form of informal and incidental learning. So this is big. This is very important to our intellectual growth. Very importantly, learning only occurs if there is cognitive engagement. So we thought that we would use the measure of learning, of incidental learning, as an indicator of whether cognitive engagement occurs in interactions with the AI or not. So we assumed that for simple explainable AI, where we just give people decision recommendations and explanations, given our prior results, there would be no cognitive engagement and therefore no learning. But we also expected that with cognitive forcing, there would be cognitive engagement, and therefore we would see evidence of incidental learning. The study that we designed was one where people were asked to make very simple decisions about nutrition. They were asked which of two meals had more protein or fat or carbohydrates or fiber. In the baseline condition, they were just asked to answer this question, no feedback. In the simple explainable AI condition, people were actually given decision recommendation and an explanation. And in the cognitive forcing condition, people would first make their decision, indicate that decision, then they would get the recommendation, and then they would have a chance to revise their choice. Before I show you the results, let me explain the two baselines. So one baseline was when people received absolutely no feedback, no assistance and no feedback. And from prior work, we knew that this provides people with very minimal learning. And the learning that occurs is just from repeated exposure to same type of questions. Our high conditions, our high baseline, is one where people performed this task without assistance, but after each of their responses, they got expert feedback. You were correct or you were incorrect for the following reason. And from the prior work, we know that people learn from this and that it's hard to beat. So this was our low baseline and high baseline. And just as expected, the simple explainable AI did roughly as poorly as our low baseline. There was no evidence of learning with simple explainable AI. Shockingly to us, there was also no evidence of learning in the cognitive forcing setting. It caused us to revise our explanation of what is happening with cognitive forcing, at least with the update design. It's possible that what's happening is that it's not that people engage cognitively more and that's why they avoid over-reliance, but instead of over-relying on the AI, they over-rely a little bit more on the initial idea. So we reduced over-reliance, but we did not really improve cognitive engagement or overall outcomes. So far this is all negative results, like it seems that nothing works and that people make really poor decisions and do not think about anything that we give them. Is there anything that we can do better? We found one thing that seems to work a little bit better. So if instead of giving people decision recommendations and explanations, we only gave them informative explanations that were contrastive and that included some knowledge that they can build on, and all they have to do here is, so notice that the explanation says beans are a significant source of carbohydrates. So with this explanation, people can make a fairly small cognitive leap to come up with the right answer. And it turns out that making this just small cognitive leap is enough of an engagement for people to substantially learn. So we found that if we only give people informative explanations, people do engage, people do learn. So this is a very positive result for us. But in this study, we only had situations, we designed it such that AI was 100% correct. We still do not have particularly good informative results on what happens if you apply this strategy when AI can also be incorrect.
Do you think this is because it's its own kind of forcing function? Like it's not telling you the answer, it's saying here's some information and you need to integrate it? So it's not disrupting things because I'm not sure if I would call it cognitive forcing, but it definitely creates a situation in which there is no shortcut. It removes the shortcut. Rather than distracting you from the shortcut, it takes the shortcut away completely. So it gives you enough information so that you can do better than you would have otherwise. So people in this condition made as good decisions as people who were given decision recommendations, and they learned. So they performed well on the task, and they learned, so they cognitively engaged. So at that point, our hope is that in more complex situations, this kind of design may lead to more thoughtful engagement with AI-provided information and to real reduction in over-reliance, but this work is still ongoing. So in conclusion for this subsection, I want to show that more and more people are recognizing that this simple explainable AI design where you give people decision recommendation and explanation is insufficient in many situations. We have suggested the approach where we take away the decision recommendation and we just give people a useful synthesis of relevant information so that they can make the cognitive leap on their own. Many people might have heard of Tim Miller's recent paper on evaluative AI, where instead you provide people with good reasons, with informative synthesis of reasons pro and against different options so that you can make choices on your own. And then there is another recent paper from Patty Ma's group that instead just gives people questions that focus their attention on the right aspects of the problem, so they can, perhaps not spend time on irrelevant aspects of the problem and arrive at the answer themselves. And they actually found that people prompted with such questions performed better than either people or AIs alone. So they actually achieved this holy grail of complementarity, but they achieved it on a relatively simple task. So this design space is just being formulated and has not yet been evaluated. So we are still in the process of making design knowledge in this space. But a little bit in the spirit of James's talk, so some of you have seen James's talk on human-centered, community-centered, and society-centered AI. I focused so far mostly on the very low-level details of our design knowledge. But let me also ask slightly higher-level questions, which is, are we even solving the right problems? So we conducted a co-design study with clinicians on, what role AI should play in the treatment selection activities. We first designed one system, and then we met with 10 clinicians. We both first conducted a formative interview trying to understand their needs for AI in clinical work, and also got their reactions to this first design. Then we redesigned it based on their feedback, and then we had another round of conversations with clinicians who reacted to this design, the revised design, and provided new suggestions. I will not go into the details because it's a fast overview talk, but one of the key findings from the study was that clinicians, particularly in mental health, really value shared decision-making. So they really, really want to make sure that they build good rapport with the paper, that the patient is on board, activated, and committed to their health. So they really want to structure the health encounter in such a way that they collaboratively arrive at the decision, that they build shared understanding of what's going on and build a shared plan for what to do forward. Instead, what we are doing, we're bringing this new thing into the clinical encounter that takes the clinician's eyes away from the patient and to the computer, and they sit there and bang, 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 spend 3 minutes on the computer, and then return to the patient and say, treatment A. Instead, what they want is support for conversations between clinicians and patients. Could we build systems that allow them to continue the conversation together, build this common ground, make a shared decision? And for that, they say that system really needs to support an informed choice by both, which means that it needs to allow the patient and provider to evaluate multiple options and contrast them. Everybody understands that most AI algorithms only have access to the subset of knowledge that is relevant to a decision-making. They argue that this interactive system should reflect all of the knowledge that is important. So, for example, patients' preferences, side effects, and so on. And it's very important that the system allows fast and interactive exploration of what-if scenarios. Okay, if I really care about insomnia, how do my options change? If I only want to take drugs once a day rather than 3 times a day, what are my options? Right? How do I want to balance my various trade-offs related to my life? Next, the providers with whom we interacted also say that they do not want to be responsible for evaluating every single decision recommendation and trying to decide, is AI leading me astray or is this a reasonable thing? They really want us to evaluate the systems ahead of time, do a randomized clinical trial, give them the results so they can read once and know how good the system is. This said, they do not want to see an explanation for every decision. They do not want to be responsible for validating the decision recommendation. But if the system suggests something that deviates from the clinical guidelines, they would like to see a contrastive explanation that says why this particular patient should be treated as an exception, right? So if this patient has 3 comorbidities and an unusual preference that leads us to prefer an unusual treatment, they would like to see that explanation in that case, but not otherwise. And
They also point out that treatment selection is not the only decision that they make. Another decision that they can do is decide whether the patient should also see a therapist or not, whether the patient should have a follow-up in 3 months or 2 weeks. So they want us to build systems that have an understanding of the range of different actions that can be taken in the socio-technical healthcare system. The last application of AI that I would like to touch on is algorithmic recourse. So this is the situations where algorithms make consequential decisions about our lives, for example, about our loan applications, unemployment benefits, or situations like that. There is now legislation happening in many countries that demands that when systems like this are built, people are given appropriate grievance redressal mechanism. That if the AI says, you cannot have the loan or so on, people should be able to understand what's going on and be able to act on it. A key technical approach that has been taken by the AI community is to generate counterfactual explanation. So if Michael asks for some benefit and is denied, he can be told, if you only did something differently, you would have gotten this benefit. So if your income was only $10,000 more, you would have gotten the loan. So this is attractive, and many people see it as obviously a desirable thing to do because it's so easily actionable, right? You tell the person exactly what they need to do in order to get the loan next time. But built into this is an assumption that the algorithm that makes this recommendation, that produces this explanation, knows everything about what is possible and easy in a person's life. So for example, the algorithm may say, all you have to do is increase your income by $10,000 and you will get a loan, even though there are other paths through which you could also get the loan. This person may not be able to take on extra work shifts because of their childcare obligations, but they could reduce their debt by paying cash instead of using their credit cards, and it would also have gotten the loan, but the system did not communicate it because it didn't understand the relative costs of the different actions that the person could take. So because the current community is so devoted to the idea of counterfactuals, we decided to explore it and what happens when the underlying algorithm has an accurate versus inaccurate idea of what the person can do. So we conducted an experiment in which the participants were put in the role of career counselors who helped students who were just denied an internship reapply for that internship. And as part of the reapplication process, the student would have to take additional courses to build up their competence. So what the participants were given was a denial letter that included reasons. So in the counterfactual condition, the letter would say, if only the candidate had this many courses in these different areas, they would have gotten the internship. The reason codes explanation would say the candidate needs more expertise in the following areas, the pharmacology being the most important, followed by anatomy, followed by pathology. Unbeknownst to the algorithm, there is an extra component here, which is that courses in different fields are offered in different semesters. So, for example, here, in order to take 2 extra pharmacology courses, the student would have to, take courses for an extra 3 semesters, which takes a long time. So they would have to, work without an internship, for a very long time. So an objective function that the student has is to become qualified for an internship as quickly as possible. So we considered 2 conditions, one in which the reality of the student was aligned with the model of the algorithm that produced the explanation, and a misaligned one where the student's costs, as reflected by the schedules of available courses, were misaligned with what the underlying algorithm thought would be the quickest way to make the person eligible for an internship. So counterfactuals are really attractive because they're so easy to interpret. They exactly tell you what you need to do to succeed, whereas reason codes, perhaps give you a larger range of options, but they perhaps make it easier to make a mistake. Interestingly, we found that people in both conditions were equally likely to correctly reapply for the internship, But very importantly, people in the reason codes condition took fewer selected actions that would require fewer semesters of course taking to become eligible than people who were presented with counterfactuals. So people who were presented with counterfactuals had one path that they could follow well, but if that path was not optimal, they didn't have enough information to figure out what else they could do. Reason codes, they gave them enough information to make correct decisions and to make several correct decisions, and giving them an option to choose one that was optimal for them. We also conducted a follow-up study where we compared reason codes to feature attribution, where you give people more detailed information about the impacts of different features, and the difference between those was relatively small. And we also conducted a third experiment in which, instead of providing a single counterfactual, we provided multiple diverse counterfactuals in hopes that that would give people some broader idea of what's possible, and that for the fully misaligned condition did not, again, resulted in worse outcomes than giving people the reason codes. So this is perhaps a small nitty-gritty thing. So let us also look at the, again, larger picture of, how we might deploy AI and support people who are applying for public benefits or other resources. So we conducted a study of two settings in which algorithms are currently not being used. We just wanted to see how people currently apply for things. What does the application process look like? And in particular, we wanted to see how people react to negative decisions and how they process the negative decisions. We interviewed the beneficiaries who are applying for things. We interviewed the bureaucrats, and we also interviewed people from organizations that support the beneficiaries, people who provide advice on how to apply and how to navigate the system. We conducted the study in two settings. One was in Boston metropolitan area, and we looked at people applying for housing assistance. And the second setting was people applying for land to build their homes near the Chennai metropolitan area in India. These were comparable comparable settings, and again, algorithms are currently not used in these settings. We wanted to understand how the decision-making is currently happening so that we could make thoughtful decisions about how to deploy AI in the future. Some findings were the following. So interesting things already happened before people even decide to apply. It turns out that many people, particularly people from marginalized groups, often do not know or do not believe that they're eligible for a particular benefit. So they need to be told, and intervention is needed to help them decide that they are eligible. And they then also need to figure out what are the prerequisites for applying. So for example, in order to apply for land, you first need to have an identity card, and you need to have something else. So there are often multiple other bureaucratic steps through which you have to go to succeed. Then during the application process, one implicit assumption that we are making as a computing community is that the application is kind of effortless, that you sit down, fill it out, and it goes. But it turns out that often collecting the information is effortful and costly. And the more detail you provide, the more successful your application can be. But people rarely provide all possible detail. People satisfies. Next, in Boston metropolitan area, we also found that there is often a step of pre-denial. So before people get officially denied something, they get notice that they are about to be denied. It differs from denial because at the moment of denial, consequences kick in. Pre-denial, you are just told denial is about to happen, but the consequences have not yet been triggered. So this is a brief period in which people can say, oops, there is information missing, there has been a misunderstanding. Then when the denial occurs and people get the denial, it turns out that they typically process the information emotionally rather than intellectually. So potentially, giving them informative explanations is not the most impactful. Then there is the process of appeal in many situations. And during the appeal, often what people do is argue that they are a legitimate exception to the rule. And Michael knows everything about discretion in public service, right? So a very important part of bureaucracy is that correct application of discretion. And a very, very important finding was that, particularly for marginalized populations, a lot of applicants were supported by accompagnators, people from various nonprofits and other institutions who would guide them throughout the process, provide with both moral and practical support throughout the whole thing. So now, with these findings in mind, we can realize that there are many places where human-centered AI could be deployed that are much more impactful than just creating counterfactual explanations. So we could be proactively identifying people who are eligible but who are not applying. We could be providing people with personalized plans for what they need to do in order to, to be able to apply, what other things they need to do. During the application process, we can provide them with personalized recommendations for which types of information they should prioritize and how they should present it to be most informative to the decision maker, so they do not get denied simply because the relevant information was missing. Perhaps during the denial, when people receive the denial letter, currently through the counterfactuals, we support them in deciding what they can do better next time they apply. But another decision they actually have to make is whether they got denied for legitimate reasons or whether they actually have a good case for arguing that they're an exception and they should be treated a little bit differently. So currently, the way we communicate denials does not provide people sufficient information to make that decision well. And when people do get denied and decide to appeal, we can provide them with personal guidance on how to structure that information. And throughout the process, we really shouldn't just be supporting the beneficiaries. We should also be building the tools for the accompagnators. So, how many people have read at Kentaro Toyama's Geek Heresy? Law of amplification. A number of you have seen it. He often argues that the best way to intervene is not directly, but indirectly. You have to find the person who is actually capable of making good use of your intervention. And often the direct beneficiary does not necessarily have the time, resources, or the perseverance to be the right recipient of your intervention. So again, under realistic assumptions, the counterfactuals that we are producing do not even meet the goals, the stated goals for which they are being designed. And goals are actually larger. Even at the denial stage, they should be not just telling people what they should do next, but they should be supporting the decision whether people should reapply or argue that they're an exception. And even more broadly, again, kind of stepping into James's territory, we should be thinking about other places in the application process where AI could be used to intervene for the benefit of people. So to summarize the specific takeaways, I told you about the adaptive user interfaces and the design knowledge that we have produced there, and in particular this really cool design pattern of split interfaces where the AI-powered solution is an alternative rather than a replacement for what people currently do. In the context of decision-making, I'm arguing that the current simple explainable AI is probably insufficient in most cases, that giving people decision recommendations and explanations does not lead to more thoughtful, more engaged, better decisions. We really need to be thinking about very different paradigms for this interaction. And when we think about algorithmic decision-making in situations like provision of public benefits, we focusing on communicating denial explanations through counterfactuals doesn't even meet the stated goals, and it's the wrong place to intervene. And at the large level, I want us to celebrate the fact that as the human-AI interaction community, we have already produced a whole bunch of very useful knowledge, but things are moving so incredibly fast right now that we often just come across ideas that sound pretty good and we say, yep, we are going to build on this. We are going to do explainable AI. Yep, we're going to do counterfactuals. They're just so easy to follow. And we just turn them without verifying into the foundational aspects of their body of knowledge. And adopting these ideas without verification can have pretty negative consequences downstream. And in the language of Silicon Valley, we need to accelerate the production and systematization of the design knowledge related to human-AI interaction. So this is really badly needed, not just create new products and applications, but really try to make sure that we have solid basic knowledge to build on. And this is it.
All right, we've got some time for questions, feedback, comments. Call it.
Okay. And if you could say your name.
Yeah, and thanks so much for your talk. I was wondering, in the context of the decision making, if knowing that the AI model was like 50% correct or 70% correct could potentially change how the humans might like take the advice of the AI.
Yes, it does make a difference. And there is another very interesting study in psychology that shows that knowing this only works if you are re-reminded every time you make a decision. So it's not enough to just tell people once, you actually have to re-remind them at every decision instance.
I'd love to dive in. So you made an almost offhand comment early on that, well, obviously, if you have two inputs that are making uncorrelated errors, then ensembling them is sort of the right solution.
Mathematically.
And, yeah. So just reapplying that, given everything you've said, should we be taking people in AI out of a loop together and instead just be having independent judgments and ensembling ourselves?
So I think several people have tried that, and intellectually it's a very appealing thing to try to do, except that the reason why we have human oversight in decision making is for legal and ethical reasons. So we want the final decision to be made by the human. So even though this independent ensembling can produce very good decisions, this does not solve our societal need for having the human ultimately take the responsibility for the final decision.
Right. You would then need to have someone look at the ensemble decision. Can turtles go up or only down?
I'm thinking that if we do that, then the final decision maker might be over relying, but they would be over relying on a slightly better input.
That's right. Yeah.
So,
I mean, it's like you have a closed loop system there, where maybe as long as you're amplifying a better signal.
Yeah, but we still want to make sure, and you're next, that we want to make sure that people honestly understand why they made the decision, and they can be like honest to goodness accountable for the decision that they've made, and that requires understanding.
It does even seem possible, and then I'll be quiet, that maybe you could gather the human input in such a way that to the oversight, you can't tell whether each piece of evidence came from a person or an AI. Might help debias certain of these things as well.
People do occasionally treat machine and human input differently, depends on the domain.
Yeah.
Yeah, it's intriguing to me, Krzysztof, that a lot of the support for decision making comes from an analytic approach. And in psychology, behavioral science, there's a lot of data summarized, I think, by Kahneman Best and Picking, Gajos, and Slow, that a lot of these decisions are propelled by an emotional feel, a gut instinct, if you will. And I'm wondering how that works its way into some of these experiments to try, particularly, and then explaining some of your findings.
So all of our experiments, the experiments that we conducted were kind of in an emotionally neutral setting, so that there were good preconditions for analytical thinking. In other experiments that I didn't talk about, we explored the effect of time pressure, and we saw that it can substantially increase over reliance. We have not worked with emotion, but I can totally see how that would impact things. So Dr. Sanders is actually a physician and has thought about clinical decision making, so I'm inclined to listen rather than talk.
Yeah, no, I just think it's if anybody and slow, I really recommend it. It's really a lot of data to suggest that these decisions we think are analytically based, our own decisions, are actually are not driven by analytic thinking. And I think it might have some implications.
So I removed references to Kahneman from the talk because people have a very specific view of that work, like analytical good, heuristic bad. But the dual processing theories actually posit that they're just different ways of making decisions. So the system one, the heuristic one, is a pattern completion engine. So it can actually make very good complex decisions that we are not necessarily able to make equally well analytically. So these are complementary systems, but if you apply them incorrectly, things get bad. And also the problem with heuristic use of explanations is not that people make the decisions heuristically, but that they make a heuristic that the presence of explanations indicates competence, therefore I should rely. Mm-hmm. So it's heuristic processing not of the content, but the presence. One more question, and then people will start running away. Okay.
I want to extend that same thought a little bit. There are lots of situations where you need to do decision making very, very quickly. And putting human in the loop in a lot of those situations, it kind of doesn't work. So do you have any recommendations for how to improve the quality of the AI joint human decision making process when you've got to react quickly?
We now have evidence that time pressure is bad. So we've got an introduction for the next paper. Okay.
Well, so I fully agree with you that we need to accelerate deduction and visualization and design on. But I'm still worried that the people who are hastily turning to productizing AI may not even be paying attention. So do you have any thoughts about how to make those things?
I would welcome your and Dan's suggestions, given that you actually have seen companies from the inside.
That's what makes me worry.
All right, it's 11:30. I've been told that people run to other classes. Thank you.
Thank you.